Should be recording now. Welcome to this problem review. I'm going to be working on a problem that's not in your textbooks. I just found it online. And what we have here is this weight, which we are going to say is, let's call it, say it weighs 50 kilograms. And we want to find the moment caused by this force about point X. So, the moment caused by weight about point X. This one. So, we have to consider how we're going to go about doing this. Well, what is the definition of moment? Well, there are a couple of definitions. We have a moment about some point C is the cross product of the distance vector with the force vector. We also have the moment is equal to the distance times the perpendicular force. And I think we should take a look at our picture to see which one works best. And I see that computing the perpendicular distance is going to take. Interesting. So if the force goes down like this, which means we want our perpendicular distance to be this distance. Well, that distance isn't really given to us, now is it? But we do have these really nice angles here that are given to us, the distances, which means we can use trigonometry to figure this out. We're going to call this one D1 and this one D2. Now then, if we look at the D1, and we see we have the hypotenuse length and the adjacent side for the A. This is hypotenuse, and this is adjacent. And if you're trying to keep your trigonometry together, remember that cosine has a companion, which is the adjacent part, length. And in this case, we do have the adjacent length, so we're going to use cosine. So, this cosine of 30 degrees is going to equal the adjacent, which is D1, over the hypotenuse, which is 12 inches. So then D1 is going to equal 12 cosine 30 degrees inches, which is not a pleasant number. It is 12 times root 3 over 2 equals 6 times the square root of 3, which is, calculator, 10.39 inches. Alright, let's look at D2. D2 we have 40 degrees, and once again we have the hypotenuse and the adjacent. So we do it again. Cosine of 40 degrees is equal to D2 over 13 inches, which means that D2 equals 13 cosine 40 inches, which is 9.959. And so the total distance D is 20.4. Yeah, we're just going to do three significant digits. I like three digits. So we have 20.4 inches in our distance, and we have a nice perpendicular force, which means we don't have to worry about the angle, so it's just going to be the force times distance, and our force equals the mass times gravity. We're going to call gravity 9.8 meters per second squared. We already had our mass of 50 kilograms, so 50 times 9.8 is 490 newtons. So if we take our force and we multiply it by our distance, we have M equals 490 newtons times 20.4 inches. Going to equal 9,996 Newton inches, which I just realized we have a combination of SI units and American units. Whoops. Ah, well, doesn't matter. Which is equal, but it comes out to this nice engineer's 1,000 Newton inches. And if we wanted to, we could convert that into a more succinct unit, but I don't know. Well, I will. We're going to change this. We're going to say that the force isn't that. We're going to say that it weighs. What's a good weight for a nice big bicep like that? I'd say 50 pounds. What's a good weight for a nice bicep curl? Nice big chops. Okay. Well, we got some big chops there, so that becomes 1,020 pound inches. And there we have our answer. So, let's talk about what we learned here. Well, we talked about moment equals force, perpendicular force, times the distance. And by perpendicular, we mean perpendicular to the measured distance. For example, if we have this, a sheet plate, there's its center of mass, and say it's a 5 foot by 5 foot square plate, and we have a force here of 30 pounds, then you might be tempted to take this to be the distance, and then this as the perpendicular force. Of course, if you did that, you'd be doing a lot more work, because it'll turn out that if you do this method, it's going to be the exact same way if you took this method, this distance, and multiplied it by this force. So 2.5 times 30 pounds. Which, if you really want me to do this, alright, this is 35 pounds by the way. This difference is going to be 5 root 2, because we have a square, so the ratio is 1, 1 square root 2 times 5 is 5 square root 2, 5 square root 2. If you really want to do it, 5, the square root of 2 is equal to the square root of 2 times 5 squared. Over 2, because it's half of it. So here our distance is 3.53 feet. And this angle is 45 degrees, so this comes out to be 30 pounds. The other standard cosine, it doesn't matter. We're going to multiply by square root of 2 over 2 anyway. Which is 21.2 pounds. And so we get 21.2 times 3.53, which is 75. Oops. Foot-pounds. And I've just proven to you that you really don't need to think that hard about this. So just think about what this is perpendicular to and notice that distance. That's a good way to go. So instead of thinking about, oh, I have this distance between them, how do I get it, the perpendicular component of the force, say my force is pointed in this direction at what's the perpendicular distance to the point. And that'll work, as we have just proven. We also talked about keeping straight straight. So this is a good mnemonic device. This is my signal for mnemonic device. It's a little brain. It's a brain stem. It looks like a piece of broccoli, but it's a brain. It's a mnemonic device. A cosine. For cosine, we have this co as in companion, or cohort, or conspirator. Anyway, the point is that co equals with. And so refers to adjacent. And we also talked about when you come up with problems, keep your units consistent. Sorry, that was more my fault, but still. Well, I hope this video was helpful, and I'll see you next time. And